In this video, we're going to define and explain terms related to scientific notation, estimation, comparison, and scaling. So let's briefly describe scientific notation, how it is useful for writing large and small numbers, how it is useful for making approximations. So the correct answer here is C. Scientific notation is a format in which a number is expressed as a number between 1 and 10, multiplied by a power of 10. Is useful for writing large and small numbers because it offers a way to save space and avoid errors in calculation. Scientific notation is useful in making approximations because it provides a quick and easy way to check if calculated values are reasonable. We'll talk about orders of magnitude later in these definitions, and that's what they're talking about, that you can see if you're in the right ballpark with your answer. Explain how we can use estimation to put numbers in perspective. Estimation allows for values to be approximately calculated based on educated guesses and logical extrapolation. Estimation can be used to find the number of drinks consumed at football games in 1 year by multiplying the attendance per game with the drinks consumed per attendee, and then multiplying by the number of games per year, where each component value can be approximate. And then what is an order of magnitude, and explain why such an estimate can be useful, even though it may be as much as 10 times too large or too small. An order of magnitude estimate specifies only a broad range of values, usually within 1 or 2 powers of 10. These estimates are useful because they provide a way to easily tell the difference in groups of values, such as population. So again, these orders of magnitude are usually based off of the place value that we're talking about, and then rounding to see if it's closer to the next place value up or down, and so on. And you'll learn more about that in your science classes than we're going to do right here in this math class. But explain how we can use comparisons to put numbers in perspective. Comparisons allow numbers to be put into perspective by relating to understandable values. For example, the amount of electricity a power plant produces can be compared to the number of homes it can supply. So let's describe 3 common ways of expressing the scale of a map or a model. Scale can be described verbally in words such as 1 centimeter represents 1 kilometer, or graphically, such as a marked mini ruler on a map, or as a ratio where 1 unit is described in terms of another. How would you show the scale 1 centimeter equals 100 kilometers graphically? You would use a mini ruler that's 1 centimeter long and mark it as 100 kilometers. And how would you write 1 centimeter at equals 100 kilometers as a ratio? So 1 centimeter is 1 times 10 to the negative second meters. 100 in kilo means times 10 to the third meters. Meters will cancel. So this is 1 over 100 times 10 to the fifth. It's 1 over 100 with another 1, 2, 3, 4, 5 zeros. So that's 3, another 3, so that's 10 million. 1 to 10 million. Explain how we can use scaling to put numbers in perspective. Scaling can be used to represent data without showing its actual size. For example, a timeline represents time as length. And you may want your calculator for this. You may be able to follow along as I perform the calculations myself. So the Earth is about 12,760 kilometers in diameter and about 150 million kilometers away from the sun. 50 million kilometers. Okay. Away from the sun. And the nearest star besides the sun is 4.3 times 9.5 times 10 to the 12th kilometers. Okay. Because that's my unit for light years. All right. At the scale of 1 to 10 billion, let's figure out how far away these would be on the scale model. So this is going to be 10 billion is 1 over 10 to the 10th power. So this is 12,760 times 10 to the third times 1 over 10 to the 10th. Meters will cancel, and we end up with a power of 10 to the negative 7th. Let's pull this over in scientific notation 1, 2, 3, 4 places. So 1.276 times 10 to the negative third. Negative third is the unit for, is the same as the prefix milli here. These do not cancel. These are meters. These are meters, and so these are millimeters. This is 150 times 10 to the 9th meters times 1 over 10 to the 10th is 10 to the negative first. It's going to give me 15 meters for the distance in the scale model between the Earth and the Sun. And yeah, grab your calculator for this one. So this is going to be 4.3 times 9.5 is going to be 40.85 times 10 to the 15th times 1 over 10 to the 10th. That makes this 10 to the 5th. And so this is 4.085 times 10 to the 6th meters. They're only going to kilometers here, so I need to make this 4,085 kilometers, and they're going to round here to 2 significant digits because my original measurement was in 2 significant digits. So they're going to say that that's about 4,100 kilometers. All right, I believe that is it for, oh, I have one more problem. So describe several ways of putting each of the following in perspective. The size of a large university, $1 billion, the size of an atom, and the sun's remaining lifetime. So the size of a large university can be put in perspective by considering how long it would take to meet each student. $1 billion can be put into perspective by considering how long it would take a minimum wage employee to make that much money. And the sun's remaining lifetime can be put into perspective by considering how many more generations could be born on Earth. All right, that's it for this video. We'll come back next time and keep talking about Unit 3B. See you for the next video.